start from now. So we have a vertical rope PQ, has its end Q attached to the top of a small lift cage. We're given the mass of the lift cage and also the mass of the block within the lift cage. We're told the acceleration is 0.2 meters per second squared, our modeling assumptions, and then we're asked to find out what the tension would be in the rope PQ. So the easiest way to work this out would be to consider the lift cage and the mass as one single object. So that's this. The overall mass of this lift plus the overall mass of the lift cage plus the block would be 50 g. No. The overall mass of the lift cage plus the block would be 50 kilograms. So the downwards weight force will then be 50 g. And the upwards force would just be the tension in the wire, T. We're given the upwards acceleration, which is 0.2 meters per second squared. So this is our force diagram for the lift overall. And we're trying to work out tension. The resultant force must be upwards, as the acceleration is in that direction. So our equation of motion would then be T minus 50 g. That would be the resultant upwards force. That would be equal to ma. The total mass of the lift cage plus the block would be 50 kilograms, times that mass by the acceleration of the system, and that's our equation of motion. And then we just rearrange. So T is then equal to 50 times 0.2 plus 50 times g, and this will end up being 500 newtons. And for part B, we're asked to find out the magnitude of force exerted on the block by the lift cage. So let's consider the block. So here is the block. We know the weight of the block is 10 g, and there is an upwards contact force from the floor of the lift on the block. I'm going to call that R. And these are the only two forces acting on the lift. And these are the only two forces acting on the block. There's no tension. The tension acts on the lift cage itself. The weight of the lift is not considered here as well. We're only considering the weight of the block. So these would be the only two forces. And it's the same scenario as before, so it's still accelerating upwards with an acceleration of 0.2 meters per second squared. And then it's the exact same thing as what we did before. So we would do R minus 10 g is equal to mass, just that of the block, times 0.2. And then we just rearrange. 10 times 0.2 plus 10 times 9.8. And that would be 100 newtons, which would be our answer. So for these kinds of questions, it's often better to consider individual objects. So whenever you have a lift question and you're given some kind of block that's within a lift or a person within a lift, if you're trying to work out the force on that person, then consider the person individually. Look at only the forces on them, and when you break down that scenario, you should be able to work out normal reaction force or acceleration, whatever it may be. Whenever you're trying to work out the tension in the rope on the overall lift, consider the lift and all its occupants as one single object.